Okay, so the other two functions I wanted to look at this morning are the exponential function and the logarithmic function. I think those might, maybe not the exponential, but the logarithmic might be giving you a little bit of stress. So let's look at how these functions work and how they're related to each other. That's the key on the log function, because log functions are kind of hard. So let's look at, or I guess they're hard when we don't use them very often. If we use them every day, we would start to think that they were easy. Okay, so here is our exponential function. And they said on this one, let's make it base 2. Okay, so it looks like that. Now, one thing that I remember about this function is that exponential functions are either going to be exponential growth or exponential decay. If this number right here that's going up to the power is greater than 1, it's going to be exponential growth. If the number that's raised to the power is a fraction, it's going to be exponential decay. Okay, and let's say you forgot. Well, you can always make a t-chart. A t-chart's your friend. So there are things that we recognize, and then sometimes we end up with a function and our mind goes blank. And we don't have a calculator, make a little t-chart. Okay, so let's say I said x is -4. Well, 2 to the -4. So in case you forgot, when you have a negative exponent, that just means your exponent's in the wrong spot. That is the same thing as 1 over 2 to the 4th. That makes the negative go away. Well, that is just 1/16. Okay. If I had -3, well, 2 to the -3 is 1 over 2 cubed, which is 1/8. So 2 to the -2 would be 1 over 2 squared, or 1/4. 2 to the -1 is 1 over 2. Now remember here, anything to the 0 power, it doesn't matter, a billion, a million, XYZ, anything to the 0 power is 1. And this is a very important point on the graph of an exponential function. So I want you to keep that one in mind. Okay, then it's easy from there on out. I put in a 1, that's 2. I put in a 2, 2 squared is 4. I put in a 3, it's 8. Okay, so there's our t-chart, and let's look at what's going to happen when I put that on my graph. Okay, so at -4, I mean, it's really, really close. Same thing at -3, it's at a 4th here, it's at a 1/2 here, but we know, oh man, sorry you guys. There we go, there's our 16th, there's our 8th, our 4th, our 1/2. This is the point that's very important. Okay, so if I were going to do one of these functions and I was going to sketch its graph using transformations, what I always do is I move it with that point and this asymptote. Okay, so that's what it's going to look like. So its domain, well, we could have put anything we wanted in there for x. Didn't matter. There was no value that was not allowed. Okay, the range, we can see just by looking at our graph, we're never going to get 0. There's no way we can get 0 to come out of this thing. We can get this really, really small, infinitely small. So it's going to be infinitely close to 0, but it'll never go there, and it'll never drop below that spot right there. So our range is going to go from 0, not including 0, to infinity. Okay, let's look at our end behavior on that. So as x approaches -infinity, our function is approaching 0. It's headed right towards that horizontal asymptote. As x is approaching positive infinity, I'm running out of room, our function, or our y value, is headed up towards positive infinity. Okay, so there's that function. Now comes that little pesky log function. Yuck. We don't deal with log, or we just don't have a lot of experience with them. I think some of you guys worked with those on remote learning, which is kind of a drag. Okay, so they said to also use base 2 for this. So we're looking at the function that looks like this. And now the buses are getting ready to leave. You can hear in the background. Okay, these functions are inverses of each other. Okay, so there's not a whole lot I need you to know about log functions right now. So don't worry that everything you ever learned about a log function, you had better know about by today. Definitely no. Actually there's going to be 2 things, maybe 3, that I want you to know. I want you to know that the log function is the inverse of an exponential function. Okay, let's look at how that works. So an inverse, if you recall, says switch x and y. Okay, now there's a property of logarithms, and what we do with logarithms is they're used to get a variable out of an exponent. That's what a logarithm does. It unfortunately has a word as opposed to a division sign or something like that. Okay, so even if you completely forgot that, don't worry. You know, maybe go, oh, okay, if you say so, that's what I'm going to do. Now, another property of log says that if you put a log and there's an exponent, this moves right to the front. So I can go log base 2 of x equals y times log base 2 of 2. These are inverses of each other. And again, if you forgot that, don't worry about it right now. So for right now, I want you just to trust me that these guys are inverses of each other. Okay? Well, hopefully you remember that if things are inverses, we just switch the x and the y. And we can switch the domain and range as well. So if I'm looking at my t-chart here for an exponential function, for a logarithmic function, it's going to go 1/16, -4, 1/8, -3, 1/4, and then the point, you know, I said there was a couple of things that I wanted you to remember. This is what I want you to remember. This comes up non-stop in calculus, that the log of 0 is 1. That could be the log of any base. It doesn't matter. The natural log of 0 is 1. Remember, the natural log is just a log base e. Okay, so that's going to be really important. Okay, so let's look at our graph here. So at 1/16, it's way down here at -4. At 1/8, it's at -3. So we can see it's a reflection over the line y equals x. Okay, so here, okay, at 2, it's at 1, at 4. Okay, so it looks like this. So the things that I want you, oh my gosh, I'm so sorry, you guys. I'm rushing because I have class in 5 minutes. The thing that I want you to see about a logarithm, or know, is that that's what its graph looks like. I don't care about that you know these points. I don't care that you know these points. I want you to know that point right there. Okay, that's the main point. But I want you to have this picture come up in your brain so that you remember, oh, there's an asymptote right here. The x value can never be negative. That's going to be important, and it's important that you know the log of 0 is 1. So let's put that down here, that the log of 0. And again, it doesn't, remember, if I don't put a base, that's considered base 10. Log base 50 of 0 is 1. Log base 1,000,000 of 0 is 1. Log base e of 0. Remember, log base e has a special name, natural log. Okay? Comes up all the time. So that I want you in your sleep to be able to come up with. Okay, domain and range are going to flip. And I'm running out of time because I have a class. So let's see if we can talk about these in class. All right, I hope that helps you guys.